Hello everyone. So in this segment we are going to see how did we implement the stack using linked list. Okay. So as we said, here we are using singly linked list. So the node class definition is going to we are going to use the same class definition for node. Okay. So for the singly linked list we are going to have two member variable data and next pointer which will point to the same node value. All right, and we wrote three constructors. So the default one is going to have data value initialized with 0, and next will point to the null, and we wrote another constructor which will just take one parameter for value. Okay, and next will be pointed to null, and the third parameter is going to take the third constructor is going to take the parameter for both value and the next pointer. All right, and all the accessor and mutator function, and also we just wrote a print function. All right, and then so now the stack will be our linked list. Okay, the stack will be our list. So I mean, instead of list class definition we are just having the name class stack, and obviously the operation stack is going to have fixed operation. The operation we are going to write as we listed is empty, push operation, pop operation, and pick operation. Okay, so but the initial list, the empty list or empty stack is going to be same as like a empty list. All right, so each stack will have just a one member variable which will be the head pointer. All right, and the empty stack, we are going to create an empty stack by calling the default constructor. All right, so and the default constructor will look like that. We are going to have a head pointer, and head pointer will point to a node. All right, so so empty list means we are going to have just a single node. The single node will be pointed by the head pointer. Okay, and the single node will have the next pointer pointing to the null. Okay, so just the first node, this is going to be our empty stack. Okay, so this definition is same as like a list. Now we are going to write all other operation. So is empty, push, pop, and pick. Okay, so the is empty function, we are going to write that if the stack is empty it will return true, right? So if we create a empty stack means this empty stack will have just a head pointer, and the head pointer will point to a node, and that node will point to the null pointer. All right, so that means we are going to check that the next pointer of head pointer is null or not. If that's a null, that means it's a empty stack. Okay, so let's go to the main function. In the main function we are creating a stack s, and this will call the default constructor, and initially it will call a empty stack. So this empty stack, inside that empty stack we are going to push multiple value. All right, and we are going to call the pop function, and we are going to actually see how all of the function works. Okay, and we just wrote another function, print function. Now as a stack operation we do not have actually implement them. We didn't implement that as a operation of stack. So we here implemented this function just to check all other functions and just to check the order. Okay, so so if we push multiple nodes, how this push is actually inserting node one after another. So to check that order of push and pop, you wrote this print function. Okay, but the necessary function for stack is pick. Okay, as we discussed, that means we can just look at the top of the stack and we can know the value of the top element. Okay, but here just as a simulation purpose we wrote this print function. All right, just to check the order of all elements, whether our push function and pop function is working. Okay, so in the main function we created a empty stack. We are checking whether the stack is empty. So if the stack is empty it will return true, and if the stack is empty the pick function is going to look at the stack and it will not find any value, it will return -1. Okay, so let's run that. So you can see that the first function is returning 1, means true, and the second function is returning -1, means the stack is empty, so no value in the stack. Okay, so let me add couple of, let me push couple of value. So I'm going to call push function. Let me push 10, 20. Okay, so 20 is the last item we inserted in the stack, we pushed in the stack. So pick function should return 20. Okay, and now is empty should return 0 value, means false. Okay, so is empty is 0 and our pick function is returning the value 20. Okay, now let's just add couple of other items. So 30 is dot push 40. Okay, so now our pick function will return 40. All right, so let's now let's call the pop function. Okay, so pop function is going to delete the item 40, and now my pick function should return the value 30. Okay, so here you can see we popped the item, so it will delete the value 40, so my pick value is returning 30. Okay, so okay, so that's how we are implementing stack, and you can see the all of the function is working in order of one runtime. Okay, all right, so I hope you understand stack, and I hope you can implement the stack by yourself. All right, so in the next class we are going to talk about a new data type, queue. All right, so queue is also a data type, a list, and the operation also follows a particular order. Okay, a fixed order. All right, so here this is going to follow a particular order, first in first out. Okay, now for that also the all of the operation need we are going to prefer to implement all of the operation in order of one runtime. Okay, and we are going to see all of them in the next class. Okay, and we are going to also implement them using array and linked list, and we will see the difference between them, and preferably we are going to implement them in order of one runtime. All right, thank you very much, and we are going to see you in the next class.